Hello everyone, welcome to yet another tech enthusiastic video from Simplilearn. Today we will learn about Java Lambda expressions. So without further delay, let us take a dive into our agenda for today's session. First, we will understand what exactly is a Lambda expression, why we need it, and its syntax. Followed by that, we will understand the term functional interface. Up next, we will find how a Lambda expression is a little different from regular method. That is, Lambda versus method. Then, the various variable captures possible in Java Lambda expression. And later, the method references in Java Lambda expressions. And finally, we will wind up the session by learning the best practices in using the Lambda expressions in Java. So I hope I made myself clear with the agenda. Now, let us quickly get started with the first question. What is a Lambda expression? Now, Lambda expressions were not there along with Java since the beginning. They were an update to Java since its 8th version. Lambda expressions are basically an advanced method of writing methods. To be simple, these Lambda expressions can be used inside a previously written method. This approach reduces the code length and improvises performance to a greater extent. So, we can define it as follows. A Lambda expression is a short block of code that takes in parameters and returns a value. Lambda expressions are similar to methods, but they do not need a name and they can be implemented right inside the body of any method. Now your very first question is, we had methods, then why do we need a Lambda expression that could replace the conventional method? So that's exactly where we understand the need for Lambda expressions. Now, Lambda expressions are having some impeccable features. They are capable of converting huge block of code into a tiny argument. Now, how cool is that? Now coming back into methods, when we need to create a method, we need to make sure that it belongs to a certain class. No matter that, we can create a method without having to belong to any class, but that would be just exist lines of codes lying in your project. But when it comes to Lambda expressions, a Lambda function can be created without belonging to any class. And finally, Lambda expressions can be passed around as if it was an object and can be executed on demand. Now, how do they work? And what is the functional interface? These will be the next questions. Before that, we shall understand the syntax of Lambda expressions. Then, slowly, we will move ahead into the functional interface. So, followed by the need of Lambda expressions, we enter the syntax of Lambda expressions. Now, the syntax of Lambda expressions is something which is shown on the screen right now. Now, you might be wondering if Lambda expressions have 3 different syntaxes. No. It's actually based on the number of parameters we use. So the first syntax belongs to the first type, where we have absolutely 0 parameters. The second one is preferred when we had one single parameter. And the last one is preferred when we had multiple parameters. Now, do not worry about the number of parameters used. We shall execute examples based on each and every type of them to have a better understanding of each type. Now we enter the most important topic of today's discussion, which is the functional interface. In Lambda expressions, functional interface serves as a data type for the Lambda expressions. It is represented by the annotation called functional interface. It mainly consists of an unimplemented abstract method. And when an interface is represented using functional interface annotation, or basically a functional interface can never have more than one unimplemented abstract method inside it. If you try to declare more than one, then automatically we will face a compiler error. So the functional interface can be defined as follows. A functional interface in Java is an interface that contains only a single unimplemented abstract method. A functional interface can contain default and static methods which do not have an implementation. in addition to a single unimplemented method. Now that we have a theoretical understanding of a functional interface, let us get into the practical mode where we will try to execute some different examples based on functional interfaces and Lambda expressions. I hope so far everything was clear. Now let's begin with the practical session. Now we are in the practical mode and we are on Eclipse. Now let's quickly create a project. Let's name our project as Lambda. Just finish it. And done. Now we are having a Lambda project over here and this is our source file. Now let's quickly create a new package. So by default the name of the package is same as the name of project Lambda, so it's okay, not a problem. Let's just finish it. Now let's create a new class. Yeah. So we have our class here. Now let's quickly execute the code. As you can see, this particular program on my screen is an example for a button click operation. So what exactly this program will do is it will create a button on my screen, and when I press that particular button, I'll be displaying a message called "Hello world, welcome to Simplilearn" on my console. So this particular line on my screen is an example for Lambda expression where we are trying to execute a printf statement using the Lambda expression syntax. Now let's quickly try to execute this program and see the output. So you can see that I've got the button over here on my top left corner of the screen. If I just try to press this button called click me, I'll be printing a message on my console which is "Hello world, welcome to Simplilearn." Let's try that again. Yeah, that's how it works. Now let's stop this button. Let's stop this program and continue with the next example. So this particular example is based on both functional interface and also the Lambda expression. So you can see this particular code segment is represented using the annotation called functional interface. So this is what I was talking about. The functional interface annotation, which represents a code segment that has only one unimplemented abstract method. Now let's try to quickly execute this program. So this particular code or program is nothing complicated. It's just trying to print the area of a circle. We already have a pi value and we'll just calculate the value of the area of the given circle with a certain radius. So the radius will be taken as an input from this particular code segment here. Now let's quickly try to execute this. So you can see the program got executed and the console is asking for an input for radius. Now let's type in some random input. Let's input 15 as the radius. Now we should be getting the area of the circle with radius 15. So which is around 706.83 units. I did not mention the units here. Let's consider as centimeters. So this is the square centimeter area of the particular circle with radius 15. Now let's continue with the next type of program. Now let us try to execute the next example, which is based on the both functional interface and a Lambda expression that has 0 parameters. So we discussed this before. Lambda expressions are 3 types with 0 parameters, single parameter, and multiple parameters. So this example is based on 0 parameters. It doesn't have any parameters. It's just printing one single message. That is, "Hello world, welcome to Simplilearn." That's all, nothing more than that. Now after this, we'll try to execute another example which is based on single parameter. Now let's quickly run this program and see the message. So there you go, on the console we have the message, "Hello world, welcome to Simplilearn." Now let's move ahead and try to execute the next type, which is the single parameter one. So now you can see on my screen we have another program which is based on single parameter. So what we're trying to do is here just we are sending a string of data, which is the name of a city, and we are just running through regex, and then we'll find if the data given is valid or not. So the city name that we are passing here is New York. Now let's just quickly execute this program. And there you go. We have the output. The value returned from Lambda is true. So the function that is info.matches worked perfectly. Now let's quickly get into the next type of example where we have multiple parameters. So as you can see on my screen, we have a small and simple example for multiple parameters Lambda expression. So the multiple parameters that we will be passing here are the values of x and y, and these x and y will be multiplicated with each other so that we'll be getting a product of these two numbers. Now we have the functional interface which has one unimplemented method, which is the float multiplication. Now let's quickly try to execute this and see the output. So the values passed were 100, 200 and 2 and 5. So the respective product of those two or those four numbers is been given here. So the product of 2 and 5 is 10, and the product of 100 and 200 is 20,000. So that's how the program for multiple parameters in a Lambda expression works. Now let's try to continue with our next example where we will try to print multiple elements present in a list or an array using for each loop. As you can see on my screen, we have a small little simple program which is a list, and inside the list we have a set of names of fruits, and we are just going to print these names of the fruits using the for each loop. And inside the for each loop, the control will run through a Lambda expression, which is simple print statement. Now let's try to quickly run this program and see the output. So you can see the program got successfully executed and the names of the fruits have been printed here. Now let's try to execute one last program based on Lambda expressions where we will try to use filter operation over a collection. So as you can see, we have our last program on my screen. So in this particular program, we have three variables, which is the ID of the bike and the manufacturer name and on-road price of that particular bike. So what we're going to do is we have three particular variables here, which is Yamaha, Bajaj and Hero, and the cost of all the three bikes are different. So what we're going to do is apply the filter operation and filter out the bikes with on-road cost which is greater than 80,000. So this is how it should work. Now let's try to quickly run this program. So you can see the program got successfully executed and the bikes having price greater than 80,000 have been printed on my output console here. So with this, let's continue with our next topic. So let us move ahead and learn the major differences between the Lambda expressions and the methods. So the first difference between the Lambda expression and a method is the Lambda expression doesn't specifically need a name, but whereas for a method, name is mandatory. And the next difference is Lambda expressions may or may not include parameters. We have already executed an example based on 0 parameters. And the third difference is in a Lambda expression, it does not have to return a type, but in the method, it specifically needs to have a return type. And the last difference between the both is Lambda expression includes a body as the main code segment, whereas on the other hand, for a method, code body is just another code segment of the program. So these were the major differences between a Lambda expression and a method. Let us now enter into the next part where we will understand the Lambda expressions in the form of an object. So as discussed in the features before, Java Lambda expression is essentially an object. You can assign a Lambda expression to a variable and pass it around just as a normal object. Moving ahead, we have variable captures. A Java Lambda expression is capable of accessing variables declared outside the Lambda function under certain circumstances. Java Lambdas can capture the following variables. They are the local variables, instance variables, and static variables. Each of these variable captures will be explained as follows. First, we will understand the local variables. Java Lambda can capture the value of local variable declared outside the Lambda body. Now look at this Lambda expression that implements Java Lambda interface. Right now, this Lambda expression is only referencing to the parameter value passed to it, but we can change it. As you can see, the Lambda body now references local variables str, which is declared outside the Lambda body. This is possible if and only if the variable being referenced is effectively final, meaning it does not change its value after being assigned. If the str value had its value changed later, then the compiler would complain about the reference to it from inside the Lambda body. Moving ahead, we have the instance variable capture. A Lambda expression can also capture an instance variable in the object that creates the Lambda. Here's an example for that. Notice that the reference to this .val inside the Lambda body, this captures the name of the instance variable of the enclosing company ID object. It is even possible to change the value of the instance variable after its capture, and the value will be reflected inside the Lambda. The semantics of this is actually one of the areas where Java Lambdas differ from anonymous implementations of interfaces. An anonymous interface implementation can have its own instance variables that are referred via this interface. However, a Lambda cannot have its own instance variables, so this always points to the enclosing object. Next, we have the last type of variable capture, which is the static variable capture. A Lambda expression can also capture the static variables. The static variables are reachable from everywhere in Java application provided the static variable is accessible, that is, scoped as public. Here is an example that creates a Lambda which references the static variable inside the Lambda body. The value of a static variable is also allowed to change after the Lambda has captured it. Again, the above class design is built nonsensical. Don't think too much about that. The class primarily serves to show you that the Lambda can access static variables. Followed by the variable captures, we have the method references. So method reference is used to refer method of functional interface. It is compact and easy form of Lambda expression. Each time when you are using Lambda expressions just to refer a method, you can replace your Lambda expression with a method reference. So there are three types of method references available in Java Lambda expressions. Those are reference to a static method, reference to an instance method, reference to a constructor. Now with this, we shall wind up our session by our last topic, which is the best practices to be followed while using a Lambda expression. So these are the few best practices to be followed while using Lambda expressions. The first one is prefer using standard functional interfaces. Functional interfaces, which are gathered in java.util.function package, satisfy most developers' needs in providing target types for Lambda expressions and each method references. Each of these interfaces is general and abstract, making them easy to adapt to almost any Lambda expressions. Developers should explore this package before creating a new functional interface. Followed by that, we have use of functional interface annotation. Annotate your functional interface with functional interface annotation. At first, this annotation seems to be useless. Even without it, your interface will be treated as functional as long as it has just one abstract method. But imagine a big project with several interfaces. It's hard to control everything manually. An interface which was designed to be functional could accidentally be changed by adding of another abstract method, rendering it usable as a functional interface. But by using the functional interface annotation, the compiler will trigger an error in response to any attempt to break the predefined structure of functional interface. So it is also a very handy tool to make your application architecture easier to understand for other developers. So followed by that, the next best practice that you can follow is to not overuse default methods in functional interfaces. We can easily add default methods to the functional interface. This is acceptable to the functional interface contract as long as there is only one abstract method declaration. So followed by that, the next best practice that you can follow is to instantiate functional interfaces with Lambda expressions. The compiler will allow you to use an inner class to instantiate a functional interface. However, this can lead to very verbose code, so you should prefer using Lambda expressions. And the final best practice that you could follow is avoid overloading methods with functional interfaces as parameters. So with this, we have come to an end of this particular session on Java Lambda expressions. If you have any queries regarding this session, then please feel free to drop them down in the comment section below, and our expert team will have your questions answered as soon as possible. Till then, thank you. Until next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.